Alright guys, hello and welcome to today's lesson. This is Mr. Ludden and today we're going to be having a look at algebraic inequality questions that have come up in past years on the Leaving Cert higher level maths paper. And in those we will come into contact with quadratics and algebraic fractions, both of which you would have seen at Junior Cert. And like what we're doing with these is adding another layer onto the content that you already know. And as the meme in front of you shows, you've come quite a long way since learning about the crocodile eating the bigger number for inequalities. Now, the prior knowledge, just to put it into writing, that you've done in your Junior Cert higher level, you would have done solving quadratics, linear inequalities, and algebraic fractions. Now, I've done videos on those three topics, and I'm going to put those links in the description. If you feel you need to brush up on those, they would be a great place to start. And if we look down at what's actually on the Leaving Cert higher level paper, it sort of mashes together all three things that you would have done in Junior Cert. So now you've got quadratic inequalities, algebraic inequalities involving fractions as well. So that's what we're going to look at today. So just before I start, and as always, any of the key points that I make in this video will be in the description below, and also I will pin a comment to the top of the comment section with a timestamp of each of the questions and the important parts of the video, just so that you're able to navigate your way through it as easily as possible. Right, let's get down to it. In 2013, this question came up and it asked you to find the set of all real values of x for which 2x squared plus x minus 15 is greater than or equal to 0. Now, part of that question you would have seen before, that part there, that is a quadratic. And we are going to factorize this quadratic exactly the same way as you would have for your Junior Cert. Now, the only difference between this question and a Junior Cert question is you've got an inequality there. You are used to seeing an equal sign there. But for the first half of this question, we are going to almost treat this inequality sign like an equal sign. And basically, we're going to get our roots or our solutions to that quadratic. So you can do that by using the minus b formula or the quadratic formula to give it its proper name, or you can use the guide number method. I'm going to use the guide number method here just to, I suppose, get a bit of practice. My guide number is going to be the coefficient of my x squared, which is 2, multiplied by my constant at the end, which is minus 15. So 2 times minus 15 is minus 30, and I want to find out factors of minus 30 that add together to give me the plus 1, which is the coefficient of my x in my quadratic. Now, I could write out all my factors of minus 30, but I'd be here all day. The more practice you get at this, you will see that 6 and 5 are the numbers I'm going to use. So now we just have to be worried about our signs. That right there is a plus 1. So I want my signs for 6 and 5 to sort of work with what I have so that I end up getting a plus 1 when I add them together. So I'm going to make my 6 a plus, and I'm going to use negative 5. So as we can see here, plus 6 multiplied by negative 5 will give me my minus 30, but 6 minus 5 will give me my plus 1. So my next line is going to look like 2x squared, we'll have our minus 15, we'll have our greater than or equal to 0, but we're not going to do anything with this just yet. And instead of my plus x in the middle, I'm going to have plus 6x minus 5x. Now I'm going to solve this by grouping, so I'm just going to put a line down the middle. Highest common factor between 2x squared and 6x is 2x. I'm going to have x plus 3 here. And on my right hand side here, my highest common factor is minus 5. And in my brackets, I am going to have x plus 3 is greater than or equal to 0. Now you'll know you've done that correctly because you've got x plus 3 here and x plus 3 here. Your brackets in both terms are the same. So in a much more real sense, the thing in common between this term here and this term here is my x plus 3, so I'm going to take that out as the highest common factor and just get rid of these lines here that I don't need, but I do need that 3. What I'm left over with is my 2x minus 5. So 2x minus 5 bracket greater than or equal to 0. So right now these are my factors, but I want to find out what my roots are. So if I have a factor, if I let that equal to 0, that's going to be my root. So I'm going to have the x plus 3 is equal to 0, or I'm going to have 2x minus 5 is equal to 0. For my first one over here, if I take 3 away from both sides, I'm going to get x is equal to minus 3. And I'll just take the box off that and put it on my actual root there. Or I'm going to have, on this side, I have 2x minus 5 is equal to 0. If I add 5 to both sides, I'm going to get 2x is equal to 5. And if I divide both sides by 2, I'm going to get x is equal to 2.5. So nothing new there in regards what you've learned from Junior Cert. That's just solving a quadratic. But now the fun starts. So we want to find out all the values for which our quadratic is greater than or equal to 0. Now it's very hard to visualize what this actually looks like without drawing a graph. So what we're going to do in the next step is just sketch what that actually looks like. So I'll take the important bits of what I found out. Let me just tidy that writing up there. R-O-O-T-S. I've just written out the roots of my quadratic, so minus 3 and 2.5 from the working that I did before. And on the right hand side here, I've done a very rough sketch of a graph just to show you a few bits and pieces. So the first thing I'm going to do is put my roots in on the graph. So my roots are minus 3, which is here, and 2.5, which is here. So I know that my graph is going to go through those 2 points. I also know the shape of the graph just from looking at this quadratic. We know that if the quadratic has a positive x squared, it's going to be a U shape or a smiley face, if you want to remember it that way. A positive x squared will give you a smiley face, and the opposite of that, a negative x squared, will give you a frowny face. But in this case, we don't have to worry about that because we are dealing with a plus 2x squared here. So I'll just take that away. We know that our shape of our graph is going to be a U shape, and I'll just take away the eyes there just so we don't get confused. And let's put an arrow there. And also, we have one more piece of information that we know. So if you think back to your coordinate geometry, you would have dealt with something like y is equal to mx plus c. And you would have been told that your c, let's put a box around the plus as well because that's part of it, was your y-intercept. So where your line, now remember, this is talking about a line now. I know we're talking about a quadratic up here, but I'm just linking the two things together. So just bear with me. You were told that C was your y-intercept, so where your line crossed the y-axis. The reason for that is on your y-axis, your x is equal to 0. So all your points here on your y-axis, your x part is going to be 0. So this point here would be 0 minus 1, this point here would be 0 minus 2, and so on. The x part is always 0. So if we were to put this fact into this equation, well, I would end up with y is equal to m times 0 plus c. I'd end up with y is equal to c. And that is the reason that your c, your constant, your number at the very, very end, is the point where your graph crosses the y-axis. Now, the same logic of all of this here applies up here to my quadratic. If you can find a constant there, you can note that down as the y-intercept of your graph. And of course, that's your minus 15. So So I'm just going to take this writing away here. We don't need that at the moment. That was just a bit of background info into why your minus 15 is your y-intercept. So let's just put that in. Minus 15 equals y-intercept. And as you can see, I knew this was coming in advance, so that's why I drew the graph as it was. The minus 15 is down here at the bottom. And then the last thing you have to do is just sort of sketch your smiley face through the 3 points that you have. So it doesn't have to be perfect, and we're just trying to see what the graph looks like. And it looks something like this. Now, just to show you exactly what's happening, I actually plugged that graph into GeoGebra and we got the exact same thing. I will put a link to GeoGebra in the description below because it's fantastic for, I suppose, checking your answers if you're doing graph homework, and it gives you a lot clearer of an idea of what's happening than this thing up here. So we now know what our quadratic looks like, but we want to find out now specifically where that quadratic is greater than or equal to 0. Now you might ask, well, 0, like what is that talking about? If we were to think about this quadratic as a functions question, like 2x squared plus x minus 15 is equal to f of x. You might have seen it written like that. Basically the same thing as above. Well, a lot of things similar. Obviously there's an inequality on my first one and there's an equal sign here, but a lot of similarities. The main point I'm trying to make here is the fx. That is just a fancy way of saying, well, y, like what's happening on your y-axis. So this 0 up here now, in my original question, that relates to the y-axis. So like when y is equal to 0. Now when y is equal to 0, that's a very special part of this graph. It's actually the x-axis. So like a couple of layers there to get your head around, but in short, they are trying, in the question, these guys are trying to ask you in simple English, where is this quadratic greater than the x-axis? So we're going to go to my graph over here, and I'm just going to take away this piece of writing here because I need this space. So if we just highlight the x-axis there, I'll just do that in blue, we can see that there's two parts of the graph that are above the x-axis and that will keep rising no matter how far along the x-axis I go. So we just take one bit at a time here. I'm just going to get my highlighter. We know it's going to be this part here and this part here. Everything else is below the x-axis. I'm not interested in that because I am only dealing with greater than or equal to the x-axis. Now here our roots really come into play. So you will notice that from the point 2.5 onwards, from the point 2.5 onwards to the right hand side, as those numbers get bigger, my graph is going to keep getting bigger and bigger and bigger all the way up. Like that graph isn't going to loop back down again. That's not going to happen because it's a smiley face. That smiley face is going to keep going forever and ever. So the way we would say that mathematically is, so we have this statement here, 2x squared plus x minus 15 is greater than or equal to 0. That's going to happen when x is greater than or equal to 2.5. So that 2.5 there, that's from, if we were to look back to my working out here, that was one of my roots. So from 2.5 onwards, my graph is only going to get bigger and bigger. Now you might say, oh, am I finished? Well, there's one more part of my graph where the graph is going to get bigger and bigger, and that's my other root. That's the minus 3. So in this case, anything to the left of minus 3, so as I go down my negative numbers, you will notice that my graph just keeps getting bigger and bigger there. So we've got two scenarios. We've got my graph is getting bigger when x is greater than or equal to 2.5, or when x is less than or equal to minus 3. And that right there in front of you is the only sort of extra layer onto quadratics that you're asked about in this question. So you weren't just asked to get the roots, although the roots played a huge part in this question. You were asked when your quadratic was greater than or equal to 0. So your knowledge of sketching out a graph would have come into play, and also your ability to write down what's happening in the graph mathematically. If you need to pause this video now and just make sense of what's happened here, just to make sure that this and this lines up with your graph, please do. The marking scheme says exactly what we've done as well. It gives us two methods, and seeing as this was 2013, a real exact marking scheme wasn't available at the time of asking, but I'd imagine there'd be at least 10 marks going from that, and you'd be losing about 2 marks for each mistake you make. So I had a question in class from one of my 6th years when we were doing this question. Well, sir, what happens if I only get my roots? What happens if I only got down as far as here? Well, you'd be looking at a maximum of 8 marks. Probably 7 would be a more accurate figure, but in between 7 and 8 marks is what you'd be getting. Just one more thing, you'll notice the way your terminology there, or the symbols that they use in order to tell you the parts of the graph they're looking at. That seems very tedious, a very long-winded way of saying the exact same thing that we said here and here. You're going to get your full marks for these two things here. I wouldn't worry too much about your writing in the middle. Just one more thing. I had the question, and it was a really good question. What would be the story if it wasn't 2x squared plus x minus 15 is greater than or equal to 0? What happens if it was 2x squared plus x minus 15 is less than or equal to 0? And in that case, I'll just take away all my writing here. You're looking at where your graph is below the x-axis. So that's going to be in between here and here. Again, your roots are going to come into play. So everywhere in between those two lines, you'll notice, like if I dropped a line from minus 2, I would end up below the x-axis. If I dropped a line from 0, I'd end up below the x-axis. If I dropped a line from 1, I'd end up below the x-axis, etc. Anywhere after that, you're going up above the x-axis, and we don't want that because the question doesn't ask us that. So this would be when x is greater than or equal to minus 3, or when x is less than or equal to 2.5. And you'll notice here that, like, that's fine, that's going to get you your full marks. But you'll notice here that it's a straight line. Or to explain that a small bit better, it's an unbroken line. In my other question, I had like this space here and this space here, and there was a big gap in the middle. Seeing as I have just one straight line of values for which my graph is below the x-axis, I could rewrite that as x is less than or equal to 2.5 and greater than or equal to minus 3. I could put it all as 1. But again, this thing right here and these two things right here are the exact same thing. So that was just a question on what happens if my inequality sign was the other way around, and I hope that clears up that question. I'll just get that out of the way there, because I don't want the two questions overlapping. Okay, let's have a look at another question. This question came up in 2018, and again it's an inequality question. And when you were dealing with inequalities, you would have been told that, you would have learned that, like, let's say if I had 10 is greater than 3, that's a really, really obvious fact. But if I was to multiply both of these by -1, so I'll just write multiply by -1, what I end up with is -10 and -3. Now, if I was to put the inequality sign in that, if I kept it the same way, that statement there at the bottom would be incorrect, because -10 is not greater than -3. So I have to change the direction of my sign in order to make that statement correct. Otherwise, as it stands right now, you're telling me lies, because that does not work. -10 is not greater than -3. So this piece of sort of logic, or this way of thinking, holds true for everything with inequalities. If you're multiplying across by a negative number, you need to change your signs to show that, to indicate that. And the same if you're dividing by a negative number, you need to change your signs to indicate that. Now, we run into a problem with the in this question up here, because of the fact that the first thing we would automatically do if we were in Junior Cert is multiply both of these sides, so the 2x minus 3 all over x plus 2 by 3. We would multiply them both by the denominator of my fraction in order to get rid of my fraction. However, if you look at the denominator of my fraction, the x plus 2, depending on what x is, this could be positive or it could be negative. Let's say, for example, x was 5, then 5 plus 2 would be 7, and that would be a positive answer. However, if x was minus 5, well, minus 5 plus 2 would give me minus 3. And these are two possible answers. Two possible answers. So we need to come up with a way to sort of solve this problem, because right now I cannot multiply both sides of my equation here by x plus 2, because I don't know if I need to change the direction of my inequality sign in the middle. If it was a negative number, I would need to change it. If it was a positive number, I could leave it as it is, but right now I do not know. So let me just clear my page here. So that's the main problem that we have here. Just before we go about solving that, I'll just look at the terms and conditions here and just point out one thing to you. You know that x, your answer at the very end, should be an element of R, so it should be a real number. So unless you do something drastically wrong, you should be okay there. But they also tell you that x cannot be equal to -2. And the reason for that is because of the denominator of this fraction here below. If x was equal to -2, what you would have in that fraction is 2 times -2 minus 3 all over -2 plus 2. And at the top, all is good. You'd have -4 minus 3, which is -7. At the bottom, however, you would end up with -2 plus 2, which is 0. And if you try to put that into your calculator will not be able to do it, because you cannot divide by 0. So this part here in the question, you don't need to get confused about that. It's just the question saying that there will be a range of values, but -2 cannot be one of them. Otherwise, this fraction here would not exist. It's also something we have to keep an eye on at the very, very end of our question. Okay, let's get rid of that. And we're back to our original problem now. What are we going to multiply this by to get rid of my fraction? Or in other words, what are we going to multiply both sides by to get rid of my fraction? And I'll walk you through the solution now. We're going to have 2x minus 3 all over x plus 2. And I'm just going to leave a gap, and you'll see why in a minute. Is greater than or equal to 3. So just remembering, our problem was we needed to multiply both sides by something. to get rid of the fraction. Just a bit of rough work over here. If you have 3 squared, that's going to give you 9. And if you've got minus 3 squared, that's going to be equal to 9 as well, because minus 3 squared is the same thing as minus 3 times minus 3. And a negative multiplied by a negative will give you a positive. We're going to use this fact up here. And we're going to say that, well, my denominator is x plus 2. We don't know if that's positive or negative. But if I was to square it, that's always going to be positive. It's always going to be positive, because when I square something, my answer will be positive. So I just said the same thing twice there, I suppose, just to emphasize it. So what we're going to do is multiply this side here by my denominator squared, x plus 2 squared, and I'm going to multiply my right hand side by x plus 2 squared. And the beauty of that is, right now you've got an equation where you've multiplied both sides by a positive number, so you don't need to change the direction of your inequality. The bad news is you've got to tidy all that up in front of you. So I'm going to do the first line here for you, and then we're going to skip to the marking scheme just to look at the next couple of lines and just to save a bit of time, I suppose. The first line here, getting from this line to my next line, is probably the toughest thing to do. Right then you should be on your way. So I've just written that out on a blank page here, and on this side here you're going to have 3, and you're going to have x plus 2 times x plus 2, and on your left hand side you're going to end up with 2x minus 3 over x plus 2 times x plus 2, because that right there is x plus 2 squared. Now that was all being divided by x plus 2, and I'll just put that in brackets as well. And you might be able to see on the left hand side, you might be able to simplify that a bit. Because we've got an x plus 2 as a factor up on top and a factor at the bottom, if we divide both our numerator up here and our denominator by x plus 2, what we're going to end up with is 2x minus 3 multiplied by x plus 2. So in other words, we had this here being multiplied by x plus 2 and then divided by x plus 2. So these two worked against each other, and down here at the bottom is our simplified version. Now once you spot this, you don't have to go to this step here that I'm after doing. You can go straight from your first step to this step here, and it's just a matter then of cleaning up what you have on each side of your equation, getting everything over one side of your inequality sign, solving the quadratic, and it turns into like the question that we did previously, the one from 2013. So I'm going to jump to the marking scheme now, because we've already done a question like this, and this is where we were. And if you multiply out everything, you're going to get a quadratic is greater than or equal to another quadratic. And what they've done here is they have taken everything over one side of the equal sign. So they've taken 2x squared away from both sides, so to end up with x squared. You'll notice that they've sort of rearranged it as well. The left hand side is now the right hand side, and the right hand side is now the left hand side. But if you just follow what I'm doing, they've taken 2x squared away from both sides to get x squared. They have taken x away from both sides to get plus 11x, and they've added 6 to both sides to get rid of that minus 6, and they've added 6 to plus 12 to get plus 18. If I was doing this, I would have ended up with the 0 on the left hand side of my inequality sign, and I was at 0 is greater than or equal to x squared plus 11x plus 18, but they've just switched it around. They've just sort of written it back to front, and that's fine. You'll see that they've gotten their factors. x plus 2 and x plus 9 is less than or equal to 0. And you can see that that's sort of like what I was saying in the previous question. That's your roots are going to be x minus 2 and x minus 9, because x plus 2 is equal to 0. X plus, oh, let me write that again, that was terrible. X plus 2 is equal to 0, so my root is going to be x equal to minus 2, and that's that one. And the same thing for my x plus 9. And you will see that that's the range of values for which the graph dips below the x-axis. Now, just one thing, you'll notice that that right there is a greater than or equal to sign, but you might be saying, well, you have a less than or equal to sign here, why don't I have a less than or equal to sign here? And you just got to be careful, because remember back at the start of the question, they said that, let me get rid of that, said that x could not be equal to minus 2, because then this wouldn't exist. So at the very, very end, you might think, oh, I'm done, like brilliant, and you might have this, but if you put the little line in there, technically you would be incorrect. Now, if we look over at the marking scheme, they actually said to accept that. But I suppose that's the marking scheme being soft. I wouldn't expect that every single year. You might be looking at losing 2 marks out of a 10-mark question if you didn't. So just something to be aware of. You'll notice as well, as I was saying before, if you only find the roots of your quadratic, so if you found minus 2 and minus 9, you were getting your high partial credit, so you were getting 8 marks. I was stuck between 7 and 8 about 10, maybe 15 minutes ago at this point. In this question here, you're given 8 marks for just getting your roots. So basically 8 marks for doing something from Junior Cert. So just to recap, the main part of that question was our first step there, getting sorted, and we were multiplying by the denominator squared on both sides. The reason we did that was because the denominator squared was a positive number, and we knew we didn't have to change our sign in the middle then. Okay, a very similar question came up in 2012, paper 1. And fun fact, this was the year I did my Leaving Cert. So at some point in June in 2012, I would have sat down and done this question. Seeing as this is quite similar to the one we're just after doing, I might just do the first line here for you, and then we'll have a look at the marking scheme again. So 2x minus 5 on x minus 3, I'll leave a gap, is less than or equal to 5 over 2. Now we're going to multiply by the denominator of this fraction squared. And you might ask, well, you've got 2 fractions here. You've got like 5 over 2 as well. We're only concentrating on the algebraic one, the one with x's in it. This one here is like 2.5. That's a number, that's fine. We can deal with that in just a little while. So I'm going to go x minus 3 squared, squared, and x minus 3 squared. So I'm going to jump the line that I did before, and I'm going to jump with 2x minus 5 multiplied by x minus 3. So I didn't do my line in the middle here. I just went straight from my first line here to this one. But if you don't believe me, you can put in your intermediate line there in the middle, and you're going to have less than or equal to 5 over 2 times x minus 3 squared is going to be x minus 3 times x minus 3. Now you notice you've got a fraction here, so in order to get rid of that fraction, because we don't like dealing with fractions usually, I'm going to multiply this side here by 2, and I'm going to multiply this side here by 2 in order to get rid of my fraction. So if I multiply both sides by 2, I'm going to end up with 2 by 2x minus 5 times x minus 3 is less than or equal to, now remember these are all being multiplied by each other, so I don't have to multiply all terms here by 2. I'm just multiplying one of them by 2. And of course, that's going to be this one here. So 5 divided by 2, or 5 over 2, multiplied by 2, is going to give me 5. And I'm going to have x minus 3 times x minus 3. Now, once you get to here, your job is just to multiply out brackets, bring everything over one side of the inequality sign, and I'd imagine you're going to have a quadratic there as well, so you're going to have to solve that. Let's jump to the marking scheme and see what's happening. So this is the marking scheme again, seeing as it was quite a while ago. There isn't an updated marking scheme with the amount of marks you're actually getting, but let's just have a look through. Multiply across by 2x minus 3 squared. So what they did here was they multiplied by x minus 3 squared, and then they multiplied by 2, but they did that all in one go. So they did sort of like 2 steps in one. I wouldn't really recommend going about doing that because you'd be very liable to make mistakes. But they did end up on the same line as us. If you are going to attempt doing that, just be careful because there's a lot going on. Personally, I'd like to take it step by step. They got their 2 quadratics. One quadratic is less than or equal to another. They brought everything over one side of the inequality. They factorized. They didn't draw a graph or anything. But if you wanted to, let's do it quickly. Your roots would be 5. So 1, 2, 3, 4. So x minus 5 is equal to 0. So x is 5. That would be here. X minus 3 is equal to 0. X is equal to 3. So that's going to be 5, 4, 3. So they're my 2 roots, very close together. It is going to cross the y-axis at plus 15. So 1, 2, 3, 4, 5. Ooh, it's going to be up here somewhere. It's going to be a smiley face because that's a positive x squared. So that's going to be my graph. And we want to see where those 2 things are greater than or equal to 0. So it's going to be from this point here onwards, and from this point here backwards. So let's see if they've gotten that correct. X is greater than or equal to 5. Well, that was my 5, so that's good. And x is less than 3. Now you'll notice that it said x is less than 3, and the reason for that, you might have guessed it, is if I popped 3 in here, I'd have 3 minus 3 as my denominator of that fraction, and of course I cannot have that, so that would not exist. So that is the reason that they did not put the little equal sign in at the bottom. So just something to be aware of. Right. One last question, and somewhat similar to what we were doing. I just stumbled across it when I was looking for examples to give you for this video. This question came up in 2015 and said x is equal to the root of x plus 6. X is an element of R, and you had to solve it. And you might think, oh, easy enough. If I square both sides, so square, I'm going to end up with x squared is equal to... Now remember, the squared here just takes care of the square root symbol. So I'm going to have x squared is equal to x plus 6. If I take x and take 6 away from both sides, I'm going to end up with x squared is equal to... Oh, I don't want that equal sign. Minus x minus 6 is equal to 0. And then if I was to factorize that, or you could use your minus b formula if you wanted to, I would end up with x minus 3, x plus 2. And to get my factors, I would say x minus 3 is equal to 0, so x is going to be equal to 3 if I took 3 away from both sides. Or sorry, added 3 to both sides. Let's actually do that. I don't want to skip any steps. X minus 3 is equal to 0. These are my factors. I want to find my roots. So x minus 3 is equal to 0. I'm going to have x is equal to 3. Or x plus 2 is equal to 0. If I take 2 away from both sides, I'm going to have x is equal to minus 2. Many people would have left that there, but If we just have a look at the question, it was x is equal to the root of, what was it, x plus 6. And we got answers of x is equal to 3 and x is equal to minus 2. We got to check these because, as we'll see in a minute, one of these does not work. So if I was to substitute my first example, the x is equal to 3, into this, the left hand side should equal to the right hand side. So I've got 3 is equal to the root of 3 plus 6, 3 is equal to the root of 9, 3 is equal to 3. That's all good. However, on my right hand side here, when x is equal to minus 2, I've got minus 2 is equal to the root of minus 2 plus 6. So minus 2 is equal to the root of 4. And then I end up with minus 2 is equal to 2. And of course, that right there is not correct. So we cannot accept that answer. So this question here, which is seemingly very innocent, it's just one step away from a quadratic really, had a little curveball at the end. You had to check your answers, especially when you're dealing with square roots, because one of those did not work. And if you have a look at the American scheme, 10 marks going for that, but you were losing 2 marks if you only got your correct root. You got your extra 2 marks if you noticed that, or if you checked your answers. So 20% of that question was just checking your answers. The note in here, must indicate required root. This one here, you had to tell me that this is the only one that works. So careful. Okay, that's about it from me. I'm just going to finish up with some key points, which will be in the description below. And as always, if I forgot anything or if I need to highlight something in the video that I didn't go into as much, I will put that in the description below. So just bear with me on that. Your key points with quadratic inequalities: get your roots as normal, guide number method or your quadratic formula, sketch a graph using your roots that you already found, your y-intercept, which is your number, your constant at the end of your quadratic, the sign of your x squared, whether it's going to be a positive U shape or a negative N shape. If you have your quadratic less than 0, your range of answers will be from one root to the other. So if your quadratic is less than 0, it's going to be in between here and here. So quadratic less than 0. And then if you've got your quadratic greater than 0, it's going to be from this point here onwards and from this point here backwards. That's a rule of thumb. If you want to learn those off, it can help you identify them that bit quicker. Remember to fill in the circle on your number line if you have a greater than or equal to sign. So that goes back to your linear inequalities that you would have done at Junior Cert. And just be careful with your answers at the end, because as we saw in a couple of the questions there, some of our answers need to be tweaked, especially the ones with algebraic fractions, which I have some key points on as well. For your algebraic fractions, isolate your algebraic fraction on one side for your inequality sign. We didn't really have to do that in the questions that we went through in the last couple of minutes because they were already done for us, but just make sure that you just have like the x's on one side and any other numbers on the other. Multiply both sides of your equation by the denominator of your algebraic fraction squared. Tidy it up, be careful with your inequality signs, and be careful with your final answers as well, especially in that one. I think that's it from me, guys. Again, anything that I've forgotten, anything that I've missed will be in the description below, so do keep an eye on that. Guys, thanks for listening and best of luck.